let's continue our discussion. What should p-values look like? And this is the Simonsohn et al. They're really just going to focus on the distribution of p-values in psychology for p-values less than 0.05. That's like the bulk of point estimates in their literature. In psychology, you just don't publish if it's not less than 0.05. So it's like we're not missing much in psychology anyway. And there's something actually kind of nice about this because it narrows the focus to these findings. And you can say, well, let's look at these findings. Let's look at this body of findings, claimed findings, and what can the distribution of p-values in this body of studies tell us about whether there was data mining or selective publication. These are the claimed effects. Let's evaluate the claimed effects. Let's look at p less than 0.05. There's a couple ideas, and they're very intuitive. So if there's no effect, what is the distribution of p-values? There should be a uniform distribution. Okay, that's intuitive. If there is an effect, the distribution of p-values should be right skewed. So if this is 0.01, 0.02 to 0.05, it should be right skewed. That's the idea. In other words, there should be more significant results with significance at 0.01 or 0.02 level than at 0.04 or 0.05. Obviously, the more power you have, the more likely you are going to have p-values that are really, really small. Adequate power in prospective studies, the rule of thumb is 80% power. A lot of studies probably have 50% power, or maybe 40% power. This is like a woefully underpowered study. Even in a woefully underpowered study, there are more than twice as many p-values between 0 and 0.01 as there are p-values between 0.04 and 0.05. As we get up to adequate power, this is 79% power, you shouldn't actually have many p-values between 0.04 and 0.05. 79% of the time, you're going to detect significance. And the bulk of that time, you're going to be way over here at less than 0.02. 83% of the significant effects are going to be at 0.02 or less. Okay. They next ask another question, which is, what would we expect to see if researchers are data mining? Like, what will this curve look like? The way they operationalize it here is they say, imagine you start with a certain sample, and I keep adding 5 subjects until I get a significant result. And then I stop. That's my stopping rule. So this, again, is no effect. We're in the case of no effect. And this is the real data. This is what the distribution of p-values should look like without manipulation. But if researchers are allowed to manipulate, and they simulate this, if you're allowed to manipulate and get 5 more observations until you get p of 0.05, then you get a left-skewed p curve. You get lots of observations at between 0.04 and 0.05, and very few down here. So, the intuition here is clear. And again, the write-up in their paper is very nice. They say researchers who are p-hacking have a stopping rule, and ultimately they have limited ambition. They don't seek to get down to 0.02 or 0.01. They seek to get below 0.05. So there's going to be a spike at 0.05. So this pattern reflects the goal of the researcher to sort of attain a certain statistical significance level. And, the difference couldn't be any starker, right? Instead of right skewed, it's left skewed. My favorite part of the paper is when they actually take this to some actual literature. So they go to a leading psychology journal, and they say, is there p-hacking when we look at dozens of studies in this journal? And they do something very clever, which is they say, there's studies we suspect there was a lot of manipulation on. They're experiments where the authors never showed the simple treatment versus control difference. They only show differences with covariate controls. And the question is, what do the p-curves look like? And the blue line is the p-curve. So in these studies, in a psychology journal, where they never show you the raw data, they only show you the sort of manipulated result, there are a lot of p's between 0.04 and 0.05, and very, very few out here. So based on what they just found, this is very troubling. These are studies where, taken together, we shouldn't have very much confidence in this body of literature. Just looks like those are almost certainly, if you sort of take their theory seriously, false positives out there. These are the studies where they don't think there was much indication of data manipulation. And here you have the sort of right skew.